Alright, here I have a circuit with two resistors in it. I have a voltage source, a DC voltage source, and I have a resistor R1 and I have a resistor R2. If I wanted to calculate what the voltage across just R2, I would start with looking at the input voltage. Let's say there's, let's just call it V in as the source and VO as the output voltage. So I need to find a way to relate the output voltage with respect to the input voltage. Now, if I were to take a multimeter and measure from this point here to this point here, I would be measuring across the input voltage, and I would just measure the value VI. On the other hand, if I measured from the same point across these two resistors here, I would be making the same measurement, and so the voltage drop that I would read across both resistors is equal to the voltage input. So one way that I can relate the output and the input is to imagine the current that flows through this circuit. Whatever the current is at the start of the circuit is the same as what's at the end of the circuit. So that being said, the current that's flowing through resistor 1 can be thought of as the same current that flows through resistor 2. In the real world, the current would be less at the output than what was at the input due to heat or due to other factors. But for circuit analysis purposes, you can think of whatever current is at the beginning of the circuit is what's at the output. So one thing that we can do to relate all of the components is to look at the current and Ohm's law. If there's some voltage drop across this resistor R1, and say I call that voltage drop to be V1, I could write the current in terms of Ohm's law. I could write that the current that flows through that resistor R1 is equal to the voltage drop across that resistor divided by that resistor value, R1. And similarly, that same current flows through R2 can be written as VO over R2. So with that being said, if V1 over R1 is equal to I and V over R2 is equal to I, they're both equal to I, therefore they're both equal to each other. So I could write V1 over R1 is equal to VO over R2. So that gets us a relationship between the voltage out and the voltage across resistor 1. However, we want to get the voltage out in regards to the voltage in. So what's one way we can do that? Well, we can write V1 in terms of the voltage out and the voltage in. We could say that V1 is equal to the voltage, let me make sure that's a Roman numeral 1. So V1 is equal to V in minus V out. Because, and we can say that because these two voltages, the voltage drop across R1 and the voltage drop across R2 is equal to the total voltage drop, which is VI. So now with these two equations, I can combine them into one. I can replace V1 with this expression, and I get that VI minus VO over R1 is equal to VO over R2. So I could split these up as VI over R1 minus VO over R1 equals VO over R2. So bringing this over to the right hand side, we got VI over RI, or over R1, is equal to VO over R2 plus VO over R1. So now, now I'm going to factor out VO, and I'm just left with 1 over R2 plus 1 over R1. Now, combining this into one fraction, we have VI over RI is equal to VO R1 plus R2 over R1. It should be R1, R2. Now, if I multiply both sides by R1 and divide both sides by R1 plus R2, I'm left with VI R2 over R1 plus R2. That equals VO. So if we look at this, this is telling us that the voltage out, the voltage drop across this resistor, is equal to the voltage source, or voltage in, times the ratio of that resistor over the sum of the resistors in series, R1 plus R2. So now that we know that, I want to kind of take a step back and think about what I said earlier, that there's some current going through some VI, and there's some voltage drop across both resistors. So we could think of R1 and R2 as one element in this circuit. So if I just look at it from this perspective, we had V in, and we had some element here, some R equivalent, let's say, and then we had some current going through. So let's look at let's go back and just look at an example here. Say, for example, we had a 5-volt battery, and R1 is 3 ohms, R2 is 2 ohms. Say we wanted to find the voltage drop across the resistor R2. We could use that equation that VO equals V in times the value of that resistor, 2 ohms, over the sum of the two resistors in the series circuit. So that's 5 ohms. So VO in this case equals VN, which is 5 volts, times 2 over 5. You're left with 2 volts. So right here across this resistor, we have 2 volts. So, and if we know that the total voltage drop across both resistors is 5 volts, then we know that the voltage drop across R1 is 5 volts minus 2 volts, which is 3 volts. So, keeping the resistor values, this one was 2 ohms and this one was 3 ohms. We can find the total current through the circuit by finding, we could just look at this resistor real quick, and we could find that the current that's going through it is equal to the voltage drop across the resistor divided by the resistor value. So that tells us that the current going through this resistor is 1 amp. And we could also look at the current going through this resistor, and we find again that it's 1 amp. It's 2 volts divided by 2 ohms. So the current going through this circuit is 1 amp. So if we, that being said, if we know that the voltage supplied is 5 volts and that the current going through is 1 amp and the total drop across the device is 5 volts, then we can find that the equivalent resistor value is the voltage across the resistor divided by the resistor value of 1 amp. So that means that the device has to have a resistance of 5 ohms. So we could say that this first resistor that had a 3 ohm and a 2 ohm value has a equivalent resistor value of 5 ohms. So as you can see, when resistors are in series like they are now, they can be represented by an equivalent circuit using only one resistor, which if the resistors are all in series, then the equivalent resistor will just be the sum of all the other resistors.